Hello everyone, welcome back to the channel. Now we are going to understand AWS Auto Scaling. So how does AWS provides the scaling elasticity? Basically, how you can increase the number of instances or decrease the number of instances using the auto scaling feature, which is provided by AWS. So let's understand that and see uh, basically how does auto scaling helps you, right? It helps you in the basically to give you high availability. So like if there's a lot of load, right? On say one instance, then obviously because of auto scaling, without you interfering it manually, right? Based on some metrics, there are other instances which will be actually created and which will be handling the traffic, right? So in that way, the instance never goes down. There are other instances which are added to take up the load, and in this way, the basically the application is always up. Also, what it does is basically it can also scale and create instances in different multi-AGs or between different AGs. So that's the another thing. That is why it provides high availability. Fault tolerance, obviously, like if one of the instances goes down, then obviously there are other instances which will be taking care. So if say I had only one instance running, right, and then say if it goes down because of auto scaling, what will happen? It will create another instance by itself. We don't have to worry about it. So that is the fault tolerance that auto scaling provides. Then obviously cost optimization is that when when some particular metrics, say like CPU utilization, it increases by more than 50%, then you add two instances. And then say suppose when the load decreases, right, then it basically scales in. It reduces the number of instances. In that way, it is saving your cost as well. Only when it is required, only at that point in time, it will add instances. Otherwise, it will not. And obviously, the performance improvement is there because it will add instances when there is a lot of load. So obviously the performance will be very good. So these are the benefits that you get with the AWS Auto Scaling. And then obviously the integration is seamless with all the AWS services. Now, how do we actually trigger the auto scaling? Right, let's understand that part. So, say there is an incoming traffic which is hitting the load balancer. Let's take the example of this flow where it is setting the load balancer. Now, load balancer is calling this auto scaling group. Okay. Now, when it is calling this auto scaling group, say I start with say one instance. Okay. So now currently there is only one instance which is actually serving the traffic to the client. And basically, say the load increases, the CPU utilization increases. There are a lot of other users which are actually waiting the instance. In that case, what will happen? The load will increase, the CPU utilization of that instance will go very high. And I had set basically the CPU utilization. If it is going above 50%, now it's a red flag for me. That means the load on the instance is too much to handle. So I need more instances. So here the auto scaling will actually trigger, and based on the number that I have set, right? I might say that okay, add a new instance, add one more instance if the CPU utilization goes up, or say I might say that okay, uh, add two more instances if the CPU utilization goes above such certain percentage. So all these kind of things will trigger automatically, and then uh, the instances will be launched. And since it is behind the application load balancer, obviously it can understand that okay, there are new instances and it will keep serving the traffic. So this is how it will work. And then when we say how it will launch the instance by itself, it is using the launch template. So I have created another video on the launch template. You can obviously check that video how to create the launch template. So it will create the instance using the launch template. And then obviously when we say the scaling policies, right? Whether how do we actually infer that okay, how are you going to actually infer that okay, the CPU utilization is 50% or 70% or 30% or whatever percent that you have set? It is in this Amazon CloudWatch monitor. So this actually provides that this data to the scaling policies, to the auto scaling group, and then based on that, it will take that decision. Now, the key components, obviously, I spoke about the launch template. So to add a new instance or to create a new instance, it needs the launch template. Okay. And then the auto scaling group is basically it's a group of instances. And then the important part is scaling policies. Now, what is scaling policies? See, there are different types of scaling policies that you can apply. One is target scaling. Say I say that okay, when the average CPU utilization is 50%, okay, till it is 50%, I am fine with that. It is in the manageable loads. But as soon as it goes above 50%, I'll say that okay, add two instances. Okay, you trigger the scale out process. Okay, so that's what the target scaling will do. It is based on the target. So it just maintains the target value. That's it. And once it goes below that 50%, again it will scale in. That is your target scaling. And this is the most common one that you will be using actually. And then we have step scaling as well. Step scaling is basically like you can give a workflow kind of thing. And based on the CloudWatch alarms and metrics, you can actually decide. So say my CPU percentage goes above 70%, add two instances. CPU percentage goes above 90%, add four instances. So based on the sudden changes. So up to 70%, I'm okay with whatever the number of instances, and then after that, I'm saying add two instances. Now, suppose it goes above that, it goes to 90% after that. Then I'll say that okay, add four instances. So this is step scaling basically. I'll not add the instances like six instances immediately. I will wait if the CPU percentage goes above certain level. So step by step only I'll increase the number of instances. That is why it is called a step scaling. Now simple scaling is very straightforward. It is like you are just providing a fixed number of instances, etc. When a CloudWatch alarm is triggered, and say suppose it is 80%, etc., then I'll add two instances. So it's a very simple metric that you would be using. From the it will get the alarm from the CloudWatch. Okay, say like I have set the alarm for 80%. So once the 80% is triggered, then it will just add two instances. That's it. So this is what the simple scaling is. In case of target scaling, target tracking scaling, and simple scaling, the difference is basically it is the target tracking scaling is not linked to your CloudWatch alarm, but the target tracking scaling, it will just maintain target value for a specific metric. That's it. But in case of simple scaling, it will use the CloudWatch alarm. Now, so the definition, right? The scale out. Scale out means you are adding instances. Scaling means you are removing instances. And manual scaling is like you change the desired capacity, etc. I'll show that what are these numbers. So mean, max, and desired. Mean is the minimum number of instances that you will always keep. Say suppose I have a big organization and my application is serving a lot of users, right? So I might say, okay, my minimum number is five. I always need five instances to be always up. Be it any case, whether the CPU utilization is 5%, 2%, 10%, 30%. I mean, I need minimum five. Then what I would say is max. I will set the upper limit. The upper limit could be like I would say that okay, I'll just not allow more than 20 instances. So that is my upper limit. And when I say desired means okay, you can minimum is five. It should never go down below five. And when I say desired means I would say between 5 and 20 some number, maybe seven or eight. I would say okay, my desired number could be eight. So that would be my these are the various basically numbers that you would provide. What I'm going to do is basically first I'm going to create a target group. Let's do that. For ALB and target groups, there is my another video. You can watch that video. That will help you understand how to create a target group and the other details. But for now, I'm just going to create a new target group. Let's do that. In case of auto scaling, I will just create the target group, my ASG. Now this protocol is basically for your health check. Okay, and this is my VPC. Yeah, I have this application. Uh, this is my demo application. So what I'm going to do is this application is going to actually run this particular API for my load testing. So what it is doing, it is just creating the random numbers and it is running for a longer period of time so that it creates a CPU load. And I will be doing the load test using this particular API, which is slash API slash CPU. And then there is one more API which is for my health check slash API slash health. That's it. So it just returns the health check things. Okay. So for that, I'll just set it up here. This is fine. You go to next. Now, when you're creating target group for ASG, right? You just don't mention anything here. Don't add any instances for now. We'll keep it blank. You just mention the uh, port number, your health check URL, etc. That's it. And then you just create the target group. Once the target group is created, let's do one more thing. You just need to change this attribute as well. Okay, this is deregistration delay. So what I want is, suppose when I am bringing down an instance, right? This would be useful in the scaling operation. So when I'm bringing down an instance, how much time should I wait basically to serve the in-flight request? So it will wait for these number of seconds. Actually. So now it is 300 seconds, which is like 15 or what 5 minutes, and it's 5 minutes. Now you just change it to 30 seconds. 30 seconds is fine for me, and then I will just do the save change. Now our target group is ready. Okay, now what I'll do is I will create the auto scaling group. So here you can go in the EC2 and you have this option of auto scaling group. Here I'll go and I'll just create my Before that, I'll just show you the launch template. Let me show you the launch template. So this is the launch template that we'll be using in the ASG. So what it has basically, the default version is 2 for now. And then we have this AMI, we have this key pair, everything is set. Okay. And so this is my uh, launch template. Okay. This is what I'm going to use. You said, look here, I have set the security group, I have set the instance type, storage as well, then resource tags, the network interfaces, and there are advanced detail as well. See, I have provided this role as well, instance profile role. What it does is basically it uh, fetches the code from the S3. Okay, what it is going to do is it is going to fetch the this is my jar file basically, the code that I have shown you here. I have just created this jar and I have pushed it here. And my launch template, what it does is basically first it has this instance profile. Now this instance profile, if you look into this, I can show you in the IAM also. These are very important few key things that you need to keep in mind. Otherwise, because if this role is not there, then you might end up seeing that it is not working. So this is my role. This is my role. Okay. As you can see, what I'm doing is allow list bucket, and I have given the bucket name, my Java bucket. And then what I'm also allowing is get, put, and delete object on this one. And this is the access that I'm providing to my instances. And why I need this basically in the user data, this script is executed when we launch the instance. So what it does is basically it will install the Java 21. It will create this folder opt/app. Then it will copy this AWS one.jar. It will copy this AWS one.jar. Okay, from this bucket, and then it will push it in the opt/app folder, and then it will just run the Java dash jar, this particular jar, in the background, and then we have our application running. So this is what this particular launch template does. This is very important. Instance profile, just keep this in mind, and then your user data. What I will do is I will add this user data and this role, etc., in the description. Now once this is done, now I will move to the auto scaling. So just understand the sequence. First, I have created the target groups. Now I'm moving to the auto scaling. Okay. So I'll just create the my ASG group one. Okay. Here I'm selecting this launch template, which I just shown you, which I have displayed you, right? This is the launch template. Here we have all the details. So this is my first screen in the auto scaling group. Now here you have to choose the network. See here you can see that the instance type is T3 micro, which I have selected in the. You can also override launch template. That is up to you. And I'm using the same launch template. Here I'm using the VPC. What I'm saying is launch instances in both the AZs, AZ in 1A and AZ 1B. Okay. And then in the availability zone distribution, right? So it is up to us. How do you want? So I'm just saying that balance based effort. So if launch is fail in one availability zone, AutoScaling will attempt to launch in another healthy availability zone. So one of the availability zone, if there is some issue, it is not getting launched, then it will try in the another one. Balanced only, it's basically it fails in one availability zone. AutoScaling will to attempt to launch in the so it will continue to try in the unhealthy availability zone just to maintain the balance. So here it will try to maintain the balance, but it is not necessary the balance will be maintained. Here in this case, what will happen basically is there are two AZs and I'm launching 10 instances. So one of the AZs is actually unhealthy and we are not able to launch that instance. So it will keep on trying so that the balance is maintained 5-5, something like that. And then this is reservation. This is based on the capacity reservation, etc. Based on that, it will take the call basically. It will stick with the balance-based effort for now, and we'll keep everything as it is. Now, here there is an option of load balancer as well. So right now I have not added any load balancer, so I will not add anything for now. And then we'll just skip this latest part. Okay. Then during availability zone impairment target instance launches towards other oil. So this is basically if you want to enable the zonal check. If there was any issue in the availability zone, right? Then during that process, when it is doing the impair process, right? AWS is doing that. Then it will shift all the instances to the healthy availability zone. So do you want to enable it or not? I'm keeping it disabled for now. Now health grace period, I'll just make it 30 seconds. Not going to check the EBS health checks. It is not required for me. Now here comes the group size. So which I was mentioning, right? The minimum capacity, I'll just keep it 1. Maximum, I'll keep it 3. And desired also, I'll keep it 1. So when auto scaling will trigger, it will launch one instance. Okay. So because I have kept the desired capacity is 1. If I change the desired capacity to 2, it will launch 2 instances. So it will be the number of instances that it will be running is 2. Maximum limit that it can go up to is 3. And the minimum it can go down till is 1. But for now, I'm just keeping it 1. Just keep that in mind. Right now, I'm not adding any scaling policies. I'll do it later on. Let's just ASG create first. Now, there is one instance maintenance policy also. Right. If you want to launch instance before terminating others, so this is like rebalancing. New instances will launch before terminating others. So, like say, this is launch before terminating. Launch new instances and wait for them to be ready before terminating. This allows you to go above your desired capacity. So, this is again, this allows you to go beyond your desired capacity. So, my desired capacity could be like I told you, right? It is 1 or 2. But then if I'm doing this launch before terminating again, it means I'm just going to launch my new instances and then wait for them to be ready, wait them for to be ready, and then uh, basically after that I'll terminate. So this is here launch before terminating. This is terminate and launch. Basically, I'm saying that you terminate and launch at the same time to control the cost. So this is for saving the cost. And then this is flexible behavior. We can set. I mean, you can set all these numbers. So how much do you want? So the healthy instances, how much do you want it? So all those kind of things, your numbers, etc. that you can provide. So when we say max percentage, see, we have provided max instances, right? So suppose if I add here 200 and suppose I add here minimum let's say 50, not be greater than 100. Let's make it like 100 and 200. Okay. So what will happen? Say suppose I set the minimum instances to be 5. Okay, and then my maximum instances to be 10. Just take that number. So during this replacement behavior, right, that we are going to do when there is a refresh or any maintenance activity that is happening on the instance. During that time, what will happen? The maximum number is 20, 10, right? So now because 200% means 20 instances. So it can go up to 20 instances. Just keep that in. And then when I say 100, you keep minimum 100. So I want 5 instances to be always up. If I say 50 and then say it is like 150 here, so in that case, I'm saying my minimum is 5. You can reduce it up to 3 instances. I'm okay with that during the maintenance activity. So this is how you can set the custom behavior. So for now, we are not going to use this. We will just go with the no policy for now. Here, this is the option of scaling protection. Say suppose I am launching instances, but then I would just want to make sure that it is not scaled in. When I say scaled in means it is terminated. It is removed. It should not happen that. So if you want to that enable that thing, this is like scaling protection. Once the instance is launched, I don't want that because of ASG or anything. It should actually bring down the instance. So just for that kind of protection, I can use this enable. I'm not going to use it. And suppose if you want to allow or scale in, then you have to go to those particular instances and change this scaling protection, remove the scaling protection. So that is very important. Then enable, we need to enable this group matrix collection within. Otherwise, we won't be able to really get the information about like what is the CPU utilization, etc. So this is like for the whole ASG. We'll get the complete data. This is like how you can protect the auto scaling group, uh, and then all details like prevent force deletion, prevent all deletion. So I'm just keeping it default for now. And then we just move on notification, nothing. I'm not setting any tags for now. And here we are ready for the review. I'm just going to check the desired capacity is 1, minimum is 1, maximum is 3. Here I would go here and I do the auto scaling. As you can see, as soon as I did this, see what will happen. It will immediately launch one instance. See, as you can see, there is one instance which has started. Now, in between, what I'll do is I'll create a load balancer. Let me create a load balancer. Select the VPC. I need two availability zones for my load balancer. I'm just going to use this security group. And this is my listener. Basically, my application is listening on port 8080. That is why I'm using this. I don't have any uh, Nginx server or anything else wherein I can actually do it via 80 or 443 for now. I'm just directly calling this using the port number. Now, once I do this, then my listener is HTTP 8080, and then it will forward to my this ASG target group. So you remember, right? We had this ASG target group. So I'm just forwarding it here. My load balancer is going to be created. We'll just wait for it. After creating target group, we can also create a load balancer immediately. It is not necessary that we'll have to wait for the auto scaling. We can directly do that at that time itself. That is also okay. This is my load. ASG is done. This is my instance. Let's check the instance. It's still initializing. I just wanted to check if my instance is basically running fine. We'll just check that out. It is working fine. Here we are good. Once the load balancer is up, we will do the next step of. I'm not going to use Route 53 here. I'm just directly going to use the load balancer DNS name. Now, coming here, basically, I'm going to use K6 for my load balancing. Okay. So, this is my load script actually. This is my load script. Here, I'm going to use 200 virtual users and the duration will be 3 minutes. Okay. I will just change this to my ALB URL. Okay. So, what it does basically here, I'm setting the virtual users and the duration. This is just a simple JavaScript code. And then I'm calling this http.get. And this is my API CPU, which I told you, right? This will be something that I'll be using to create a load on my instance. Once I do that, I can call this one. One more thing that I need to do is, okay, my load balancer is getting created. Now, in the auto scaling group, there are a few things that we need to do now. Integration. So we go to the integration. Now we need to integrate the load balancer with the auto scaling group. The load balancer and target group, they are set. So how do you basically integrate my load balancer with this auto scaling group or this target group with auto scaling group? So basically, you don't directly integrate the load balancer, you integrate the target group with the auto scaling group. So let's do that. So here it is going to ask. So like I'll just come again in the auto scaling group. If I click on this option in the integration, in the integrations, here you can see load balancing. Now here I'll choose the application load balancer, and this is my target group. If you remember, this is my target group. I'll just open this target group here. That it is. This is my ASG TG1. This is my target group, and this is what I'm configuring here. Just note that I'm configuring what target group. It will ask the target group. By default, my target group is actually my listener of the load balancer is actually calling this target group. Here I'm just adding the target. That's it. Now I just update it. Now this integration is done, which is fine. Perfect. Now let's do the automatic scaling setting. So there are three options that AWS provides. One is dynamic scaling policies. The three options that we had seen, right? Target tracking, step scaling, and simple scaling. So all these three would be part of the dynamic scaling policy. And predictive scaling is basically based on the predictive data that it is going to get. So based on, see here it is saying that evaluation based on 2 days, 1 week, whatever you want. So based on that, it will decide, okay, what should be my number of instances or what should be my scaling policy. So it will be doing that predictive scaling things. Okay. I'm not going to go into this one. I'm just going to show you. This is my scaling policy name, scale based on forecast. So what metrics that you want to use to do this scaling. So based on that, it will understand. Okay, so this is the, it will do the prediction from its by itself. Okay. And then there is schedule action. The schedule action is like, uh, you can say that, okay, say like my business basically, I know that Friday evening, like e-commerce site, etc. Or maybe like, you could say like a book my show site, right? We know that maybe from Friday afternoon from 3 p.m. to 10 p.m. in the night or 7 p.m. in the evening. No, 4 hours basically. You can just take that 4 hours window. So I know that basically every Friday, 4 hours, add more instances just because I know that there will be huge traffic. So something like that. You can create this scheduled action. So this is what you can do with the schedule action. So here you have a lot of options. How do you want to do this? So this is like every week and all those information that you can add here. Now we'll do the dynamic scaling. We'll start with the target tracking first. Okay. Here the metrics that I'm going to use is average CPU utilization. Okay. We can have other metrics as well like application load balancer request count. So say suppose I'm making thousands of request count, and so based on that also you can or based on number of requests count that is coming to application load balancer, it can decide. Yeah, it could be like a network bytes in and out what is happening, and then there could be another custom CloudWatch metric that you might have added. For now, I'm just going to use average CPU utilization, and once I add this metric type, I'll just set the target value. Say I set the target value as 40, and how much time to instance warm up? I'll just say 30 seconds. 30 seconds is enough. And I'm not going to disable the scaling. So say suppose after this 40 percentage, there is a scale out operation that will happen. When I say scale out means adding instances. Once the instances are added, the traffic will be divided. The load on the instances or basically your ASG average utilization will go down less than 40. So in target tracking, it will actually do the scaling process, that is removing the instances. We'll just add that. So this is done. So we'll just review again. See my desired capacity is 1, minimum is 1, maximum is 3. At any point in time, even if my CPU percentage goes above 100%, it will not go more than 3 instances. So that's what I have done in the auto scaling group. Once this is done, my load balancer is also done. It is active. I have set the script as well. I'm will do the load testing. Our instance is ready. Our ASG basically auto scaling group is ready. Let's do the load testing and see how it goes. And we'll see the scale out process. Yeah, after I created the target tracking, basically it created 2 alarms implicitly. We don't have to do anything because I had set the number for 40, right? So by default, AWS created less than 36 and it will wait for 15 minutes. So this is the conservative time that AWS takes for scaling in basically. And then this is for greater than 40 for 3 data points within 3 minutes. So this is the alarm which is created by the AWS. And see, as soon as I ran the load, now here you can see that the metrics before in the metrics here, since it got triggered, right? The alarm got triggered. You will see that the desired capacity would be getting modified. We'll just look at the metrics here. Go to classic matrix EC2, my auto scaling group, and in this I will check CPU utilization. We'll use the number here. As you can see, it has crossed 57.5. So obviously, your auto scaling should have triggered. Yes, it has triggered. As you can see, it has increased the desired capacity now. And as soon as the number is changed, it became 2 here. It will do incremental. First, it will increase 1, then it will increase 2. Okay, in this way, it will keep on increasing. And in between, our load is still running. We'll keep it running for 5 minutes. So in this way, it will maintain consistent CPU utilization. As we have seen in the alarm, it will basically check for the alarm for continuously for 3 minutes. Right now, alarm is again high, as we can see here. So basically, it is again greater than 40. There was another check within 3 minutes. So now there will be another trigger, which will increase the desired capacity. And if I go into the matrix, see, as you can see, it is 65.6 now. Desired capacity to 3 years. Now it is the number from 2 to 3. And here you will have one more instance in the running state. So this is how the scale out process works. Okay. And slowly once our load testing completes, right, our CPU percentage will come down. And once it comes down, so this is our second alarm, which is basically the alarm when it is less than 28, right, only at that point in time, and it is 15 data points. So it will check for 15 data points. Okay. That's the important point here. If utilization less than 28 for 15 data points within 15 minutes. So it will take around 15 minutes to actually to trigger the scale in process. Scale in, when I say scale in, that means to reduce the number of instances, but it will do it automatically. So we don't have to do it yourself. That is the case in the target tracking. That's the advantage that we get in the target tracking. So all our instances are running now. We'll just check the CPU. CPU has average CPU utilization has gone around 99.4. This will reduce as our load testing is completed. As our load, as you can see, after 15 minutes, this alarm has triggered. So this is less than 28 CPU percentage. And if you look at the percentage, it is like consistently under less than 28. Hence, this alarm got triggered. Now, what will happen basically? As you can see, the earlier capacity when the scale out had happened, it was 3. Now it has reduced to 2. You'll also see that the number of running instances is now 2. So it is scaling in now. There will be another scale in operation that will take place. Just wait for that. This is now in alarm. Basically, the alarm, low alarm, basically less than 28 CPU percentage. So as you can see, we don't have to configure any alarms ourselves. AWS does it implicitly, and you cannot change it. That is also one thing, right? That is another important point in the target tracking. And the scale in operation. For the scale in operation, it uses 15 data points within 15 minutes, and only then it triggers. So I had to wait 15 minutes actually to show that it has triggered. Now the desired capacity is 1. So now it has come to the minimum number. Now if I see the running instances, now it has done the scale in operation. So this is how the scale in operation works, and the scale out operation works using the auto scaling groups, as we have seen. So we had applied the load, and then it worked fine. Now we have used target tracking, right? So now what I will do is I will change this target tracking. Basically, I will delete this target tracking now. Okay. As soon as I delete this, if I go to alarms, as you can see these two alarms are also deleted. Now what I will do is I will create another dynamic policy. This time I'll use simple scaling. Simple scaling out. Okay. And here I'll create a new alarm. It is matrix classic, and the matrix that I have to select is auto scaling, and this will be CPU utilization. Selected the matrix CPU utilization, average CPU utilization. I will keep the period as just 1 minute. And what I'm going to do is, if it is greater than, this time I will just take the yes, it is fine. And then next, let's remove any notification for now. We don't need any notification. Hmm. And we will say greater. This is my alarm. This alarm is created. If I go here, I'll do a refresh. Then save the final step. Let's create alarm. Now, when the alarm is created, obviously the state is insufficient data. We don't need to worry about that. And as you can see, it is greater than 30 is selected. Now, in simple scaling, what you can do is you can add, remove, or you can set to. You can directly set to if it is greater than 30, right? So this is the trigger basically. It will be checked through the CloudWatch alarm. So here I'm using this metric. So when it is greater than 30, so I'll set to some instance. I can set to say like 2, okay, or I can add one instance. Anything that I can do basically. It is up to me. Since this is a scale out operation, I will add, and I will add 2 units, okay. And what it is saying, and for another scaling activity, it will wait for how many seconds? So I'll just say just wait for 60, not more than that. And then I'll just create this dynamic simple scaling policy. So once I do this, my scaling policy is ready. If you look at the CPU percentage, it is well under control. What I'm going to do is I'm going to run the load test again. When I'm running the load test, I could do one more thing here with ASG. Create one more simple scaling policy. Scaling in policy. I'll create another CloudWatch alarm. Same way, I'm going to select auto scaling group, and here CPU utilization metric. This is my ASG group. And I select the metric average of 1 minute period, and I will say if it is lower than 25. Next, no notifications required. Next, proceed without action. Just need to give the name to alarm less than 30. You create this alarm. In between, let's check the matrix here. Okay, it is 27% now. So our greater than 30 is not yet triggered. You just wait. Let's in between. You just configure this. So this is scaling in operation. And when I'm saying it is less than 30, you can remove 2 instances and wait 60 seconds for any. Now I have both the policies created, scaling in and scaling out. Okay. Just keep that in mind. In simple scaling, you have to have both the scaling out and the scaling in as well. It will not do automatic, right? Like it was in the target. So you have to keep that in mind. I will just check the auto scaling state here. Till now, I don't think so. The alarm has actually triggered. The alarm now it is in alarm. When the state is in alarm, it means there is an alarm has been raised. Now once the alarm has been raised, what it will do? Now it has changed the desired capacity to 3. It added 2 instances. And if I go to instances here, as you can see, there are 2 instances which have actually been started. Now let this continue for another 3-4 minutes. Now there will be a scaling process also. Once the CPU load goes down, currently the CPU load will exact touch more than 80, 90, 100% as well. High possibility. Let it do that first. All the 3 instances are in the healthy state. And if you go to activity here, in the activity, it shows what all activity has happened, what all events have taken place right from the start. So it gives all the details here. Shrinking capacity 222, 1322, So each and everything is mentioned here in the activity. Less than 30 is in alarm now. Once it is in alarm, we know what will happen basically. It will remove two instances. Let's, yeah, here you can see the desired capacity is one now. And as soon as you do that, the two instances will be removed. Auto scaling has changed the desired capacity to one. Let's see that the process will be triggered actually. As you can see, there are two shutting down operations. Okay, just taking this. You can see two instances are in the shutting down state, and only one instance is in running state. So this is how your simple scaling works. Now what I will do is we'll again go to auto scaling, and this time we will try the step scaling. We'll delete both this. So this is deleted. Now if you go to alarms, this won't be deleted because this was created by us, right? And it is not dependent on this. Now let's see. Now we'll go to step scaling. So step scaling is basically we uh, kind of provide workflow kind of thing. Say from this and this, uh, add this much instance. This and this, add so many instances or remove so many instances. So that's how it will work. So this scale out greater than 30. So if it is greater than 30, I will add more instances. So what action I need to take? I'll say add instances one when one capacity units. It's not a percent. I'm not using percent of group. I'm just using capacity units when it is when the CPU utilization is between 30 and infinite. Okay. So here what I will do is I will just change to 30 and 40. And if it is greater than if CPU utilization is greater than 40, greater than or equal to 40, less than 40, and here it is greater than or equal to 40, then I will simply add one more instance. Okay. So this is my scale out policy. I'll also create scale in policy. Same like simple scaling. Now you are just here adding two workflows. That is, if it is between this and this range, then you do this, then you do that. So that's how it will work. Now if it is less than 30, what I will do is I will do a very simple one more. Just say remove two instances when CPU utilization is less than 25. Okay, maybe I'll just make it 20. As soon as it is less than 20, I'm just adding one. You can add more steps, but I'm just adding one step here. I do a create here. My both step scaling in and step scaling out is ready. And if I look at my current CPU percentage, and if I look at my alarms, less than 30 is in alarm. And if I look at my auto scaling, okay, one desired capacity maximum three. And if I look at the number of instances, one is running. I'll again do the load testing, continuing the load testing again. Now again, I'm increasing the load. Currently, it's one CPU, one instance. Obviously, the load will increase, and slowly we'll see that greater than 30 will be in alarm. And once it is in alarm, then step by step, it will increase. Between 30 and 40, it will add one, and after 40, it will add one. So that is how it will increase. We'll just see that in the few moments. As you can see, greater than 30 is now in alarm, and once it is in alarm, it increased the capacity to 2. I'm just checking why. Okay, now it is 89.9%. Obviously, now it will increase one more instance here because it has gone past 40 as well. So 30 and 40, between 30 and 40, one instance would have been added. So here we got that instance. And if you look here, see new instance is added. There will be one more instance which will get added. We'll just wait for that. Here it clearly mentions a greater than alarm 30. Step scaling out, changing the desired capacity from 1 to 2. Instance was started in a response to a difference between desired and actual capacity, increasing the capacity from 1 and 2. So this is how it triggers. Okay. Now there should be one more event which will take place because we have that 60 seconds cooling off period, right, between the two scaling operations. So we'll have to wait for that. See, here you can see the desired capacity has increased to 3. There was one more scale out operation which took place. And if I go to activity here, I will see it has changed from 2 to 3. As you can see, again greater than 30 got triggered and it increased the capacity from 2 to 3. So this is how the step scaling worked. Now once the load test is completed, or what I will do is I'll just close it for now and we'll see that the CPU percentage comes down. Once it comes down to 20, basically this alarm will get triggered. We'll just wait and watch. If we are less than 30 is now in alarm and our auto scaling got triggered. And since it got triggered, I'll just first show the desired capacity. It changed to 1. Changed to 1. And if you look in the activity, if you look in the activity, it's clearly showing it is less than 30. Triggered policy is step scaling in the capacity from 3 to 1. An instance was taken out in response to between the desired and the actual capacity. So basically, our step scaling in policy was actually triggered. So this is how your auto scaling works using the CloudWatch alarms. And like I told you, there are many metrics that you can use your own custom metrics as well. So this is how you set up the auto scaling. We'll just check the instance once. As you can see, now only one instance is running. So this was all about the auto scaling. So just one more recap that we will do. So what we have done actually. So we created a load balancer. Basically, we first created a target group. So this target group. So this is my. It is listening on port 8080 and HTTP protocol. Okay, and it is basically associated to my ALB. And we first create the target group. You don't register any targets for now. First, you create the target group. You set the health checks URL, etc. Okay. Once you do that, you create a load balancer, and in your load balancer, you set the listener and the rules. So my listener is HTTP 8080. You forward that to target group. Okay, and that is my ASG EG1, so which is your target group. Once this is done, so your load balancer and target group is ready. Now you go to auto scaling. You create the auto scaling here. So you need the launch template. You create the launch template first, and once the launch template is created, then you put all these details, and then you create the auto scaling group. And once you create the auto scaling group, here even if you have not integrated while creating, you can change it here. So in the integrations, you can see like load balancing. You just go to this integration part. So here you can choose the application load balancer and you can select with target group. Okay, you have to select the target group, not the load balancer. Just keep that in mind. And once you do that, and you can go to auto scaling, automatic scaling basically. Here you can create dynamic scaling policy. You have 3 types of dynamic scaling policy, which I already seen: target, step, and simple. And that is how you set the auto scaling. And for the load testing, I had used some this particular script, okay, which was calling my new API basically continuously to create the load. And this was the method actually. So this was taking a lot of time, this method, and that is why we were able to generate that kind of CPU load. So thank you so much. Hopefully you would like this video. Keep supporting me. Please like and subscribe my channel. Thank you so much. I'll keep on adding new videos more and more. Thank you so much. Have a good day.